Welcome friends. Till now we have discussed about the punching and blanking operation, the mechanics of the sheet metal operation, and we have also discussed about the force in the sheet metal operation or this punching and blanking operation, which is equal to shear area into the shear strength of the material. Now we want to minimize this force. We actually want to minimize this force. So what are the methods? What are the methods which can able to minimize this force? Okay, so the one of the first method to minimize this force is that the provision of shear. Okay, so actually shear is provided to accommodate the component on the small capacity press. Okay, so here the face of the punch or the face of the die is get ground to get this shear. So actually what going to happen by the provision of shear? क्या होगा अगर हमने shear provide किया? So here with the provision of shear, whatever the cutting action is there is going to distribute for a certain time period. So see, initially what we are having, we are not having any shear. Okay, and we are doing this punching or blanking operation. So whatever the force applied by this punch was instantaneously was acting on this sheet. That's why it is a maximum force. And now what we are doing now? So we are providing the shear. We are going to ground the face of the either punch, okay, or the face of the say die, like this. So that what will happen, instead of having the entire force at a single time, we are going to distribute this cutting action over a period of time, so that F max will no more F max, that will be some lesser value than F max. But one important thing that we have to consider or keep it in mind, that the provision of the shear is going to minimize the force, this F max, maximum force only, but it is not going to minimize the work done in the shearing. Please remember, the work done will remain same without shear. This is without shear. I am not providing any shear, and here I say I have provided the shear, say shear is represented as I. No doubt this F max will not be here F max, it is having some minimum value than that. I will write it as FB. But of course the work done in without shear and in with shear will be the same. You can see, we can have the explanation for that also. Why? So here we know that no shear is provided, that means maximum force is going to utilize in the punching or blanking. So here, so what is work done? If you want to calculate work done, we know how to calculate. I already taught you, that is F max here. F is maximum into what is the distance traveled by the punch up to the penetration. Yes or no? It's K times thickness. This is in Newton meter. Now here we know that we have ground the faces of the punch and die, so that the cutting action is going to happen over a period of time, not instantaneously. So the force is going to be minimum. If I want to calculate the work done here, that is equal to, now here force is definitely minimum, so FB into, again what is now distance traveled by the punch, this KT was there in addition to KT, so this shear, this distance is added here into KT, so KT plus I. So what I made the statement, that even though cutting force is going to minimize, but the work done remains same. You can check here, see here the force was maximum but the distance was only KT, isn't it? Now here the force is minimum but distance has been increased by the amount of I. So that is the reason why, students, please remember that the work done in the punching or blanking operation with the shear or without shear are same, but of course the forces are different. Here, by the provision of shear, the force is going to minimize. Please remember, that is the advantage of provision of shear. Okay, now if we, as I told you, work done is going to be same, then equate this to what we will get? This F max into KT will be equal to what? This FB into KT plus I. Now if anybody asks you to calculate that, the force when the shear is provided, how to calculate? Force when shear is provided, that is FB will be equal to what? F max KT divided by KT plus I, isn't it? F max KT divided by KT plus I times Newton. Or sometimes if anybody asks you to calculate this value of shear provided, how to calculate? Then write for I, that is F max KT divided by FB minus KT, isn't it? So see whether it is okay or not. So I want this value of the I, how to calculate? This will come here, F max KT by FB, and this will come here as a minus KT. So this is the shear I, you can also able to calculate. Okay, now see here, now there is one important question definitely coming to your mind, that where to provide the shear. As now we have made the decision, or it is crystal clear that about the clearance, that clearance in punching operation provided on die and clearance in blanking operation provided on punch. Now same operation take into the consideration, and let us think in punching operation where to provide shear, and in blanking operation where to provide shear. So the important thing, please note down, dear students, in the punching operation the slug is going to change. Please remember, because of provision of shear, in punching operation the slug, that is the part which is coming after the cutting operation. Okay, slug, you know, suppose cutting, after cutting the slug is coming, or the blank. So if you have the provision of punch on the provision of the shear onto the punch, then your slug is going to change. How? You can see, if I am having the concave shear on the punch, so in the die your slug will be like this. Okay, this is the concave shear. Okay, if your shear is balanced shear like this, isn't it, and this is your sheet, then you are going to get the slug like this. And if you are having the unbalanced shear, so unbalanced shear like this from both the sides, okay, your slug is going to change like this. Okay, so the provision of shear onto the punch is going to change the slug. Okay, and it is okay, but it is okay that the slug actually the scrap in the case of punching operation, because whatever the hole produced onto the sheet is important for me, isn't it? I am nothing to do with about the whatever this slug or blank or disc is coming out from the die. Okay, it is immaterial for me, because I am interested only in the produced hole, isn't it? That's why now it is very much okay that I am providing the shear on the punch in case of punching operation. Okay, now what happened in case of blanking operation? We are going to provide shear onto the die. Actually, provision of shear onto the die will bend the stock or bend the material. Okay, so actually I will clear it here. See, in punching, where we are going to provide shear, of course on punch. So shear on punch, and what will the effect that is going to cause? It is going to change the slug or disc or blank that you are getting, and of course this is immaterial for you, this is scrap for you. You are interested only in the produced hole, so it is okay. Now in blanking operation, I am making the statement that the shear will be on the die, and what is the effect of that? The sheet is going to bend. So, but the slug which are coming from the die is not changing, not bending, nothing. It is okay slug, it is coming from the die. So yes, I am okay with that. In blanking operation, my entire focus is to have the disc or blank in the correct size without any distortion, without any bending. I want that. So it is immaterial for me that what is happening with the sheet. I am interested only in getting the okay slug, okay disc, okay blank from the die. So now it is, I hope it is clear. Now we are all are firm, standing on one statement that in punching operation we will provide the shear on punch, and in blanking operation we will provide the shear on die. But at the same time, if you talk about many times these questions asked, please remember what is about clearance in punching operation. It is reverse. We will provide the clearance on die, and clearance in blanking operation we will provide the clearance on punch. And one thing is universally true, that always punch will be in size. The punch size is always lesser or minimum than the die size. Okay, so I hope the concept of the clearance as well as the concept of the shear is okay with you guys. Okay, see, so in this way actually we have discussed about the force is going to get minimized by the application of the shear. Okay, now how much shear is going to provide? Actually we know that our maximum force is what? Say in terms of the circular hole, I am taking as pi dt into tau is shear strength of the materials times Newton. Okay, so if you look at, I will take one as a theoretical question. So here we are going to see that after provision of the shear into the punching operation, how this load is going to get minimized. So how this F max is going to be minimum. That is, we are interested to find out the value of FB with the provision of certain amounts of shears, and how much that we are going to select or take, we will see here. So let us say this is also explained with the trapezium curve. Okay, so this curve will show here the punch travel, and here will be the force. Okay, so it is actually like this. The force increases to the maximum and it will complete the thickness of the plate, and then it will come down like that. So let us have the first case, that the shear I am going to provide in the operation as the thickness of plate by 3, that is 1/3 of the thickness of the plate. And every case I am going to have the penetration is 50%. I am having the penetration is how much? 50%. Okay. So just we are going to see in this case, I am draw the diagram here also. So this is my, so little bit bigger sheet thickness I am showing here. Okay, this is a sheet, and now I am going to provide, I will draw it here. See, this is a thickness T, and now my punch is here. On this punch I am going to provide the shear. The first case is how much shear? It is a thickness by 3. So I will make the 3 parts here, 1, 2, 3. So this much shear I am going to provide here, T by 3. The force is going to apply F max. And which shear? It will be FB now, isn't it? Because shear is going to provide. Let us see. We know that what is FB, and at the same time we will plot this trapezium curve also here. Okay. So what is, say in first case, FB is equal to what? F max KT divided by KT plus I. So K is what? 0.5 times T divided by K is 0.5 times T plus I is how much? We are going to provide T by 3. Isn't it? Then tell me what is the value of FB in terms of F max? 1 divided by 3 plus 0.5. 0.5 divided by answer. It is 0.6. So this is point. FB is how much? 0.6 times F max. So you can see here, for the first case, when I provide the shear as 1/3 of the thickness of the plate, now my force with the shear is going to be 0.6 times of F max. That is, there will be the 40% reduction in the load or force. Yes. So if I plot here this force or load versus this punch travel, initially there was no shear, so the punch travel was how much? The KT only, isn't it? So for KT you are having the maximum force, say like this, and this was what? Maximum force. Okay, now what happened? The force is going to be decreased by 40%. Say 40% is decreased force, but the travel of the punch is increased by how much? This KT plus T by 3, isn't it? So in addition to that, now it is say KT plus T by 3. Okay, so this is the FB1. Of course, there is a 40% reduction in the force by the provision of shear how much? T by 3. Let us say next case, that is I is equal to half of the thickness and K again 50%. Please students solve. You will get FB as 0.5 times F max. Okay, so here you can get the reduction in the load directly by 50% when we apply the shear as T by 2. Let us apply here. So T by 2 means this much. Shear is going to provide on the tool, that is our tool is punch, isn't it? Okay, so this is the shear T by 2, and of course now in addition to KT, you will have this distance kt plus t by 2. This distance will be kt plus t by 2, and now the 50% reduction in the load. Okay, so this is FB2. But at the same time, dear students, look at the tool. Our tool is the punch and die. We are providing the shear on the punch. As we are go on increasing the shear on the punch, let us see what is happening with the tool. Now the tool is going to be weaker and weaker. See, no doubt, load is going to decrease. It is taking a pinpoint shape, isn't it? But at the same time, the strength of the tool is going to decrease there. Please see. Now again, if I go for the third case, that is I is equal to T and K is equal to 50%. Tell me what will be the FB. So I hope it is nearly, there will be the value of, so 0.33 times F max. Okay. So again, see, load is coming down and down. Okay, so when the thickness I is equal to thickness, this much shear I am going to provide, that is this distance now, kt plus t, you can see here. Now your load is going to be decreased by 67%. Load is going to be decreased by 67%, but your travel of the punch is going to be kt plus t. Okay, so in any regards, you can see here either load is decreasing but the travel of the punch are increasing, so work done is, again you can see, same here. But what is happening with the tool, that is very important thing here. Now say last case I am taking, when this shear provided on the punch, I will take it as 2 times the thickness. K is 50%, K is 50% penetration, K is whatever, penetration is 50%, then you will get the FB is around 0.2 times of F max. Let us check. Don't believe on me here, you can check it. So it will give us around 80% reduction. See, 80% reduction. Oh, everybody is very happy that we are getting the reduction in the load by 80%. Very happy. अरे भाई, लेकिन टूल का हालत क्या हो गया देखो, 2 times of thickness, say 2 times of thickness. This is my shear now, this is my shear. So I am rubbing this, please see, look at this. When my tool or punch is provided by the I is equal to 2 times thickness, what happened with my punch? Okay, so definitely the tool life drastically come down by 50% when you are providing such a kind of shear. And it is not accepted at all, no one going to provide this much shear. So please remember that. See, this is because of the provision of shear. Every case I have shown here step by step what is the effect on the tool. So definitely please remember that the maximum shear that you can provide onto the punch in the sheet metal operation is up to when I is equal to thickness maximum. Beyond that, if you are providing shear, no doubt forces are coming drastically very down, but also tool life is going to be come down by 50%, more than that. So this is not at all acceptable, please remember. So what is the maximum amount of shear provided? It is equal to the thickness of the plate, not more than that. And please remember, work is not going to change, work will be remain same with the shear and without shear. Okay, so students, after seeing the method for reducing the force, that is we have seen only first method in that is the provision of shear. Now what is the second method? That is the staggering, that is the staggering of punches. Staggering of punches. So see here, basically this staggering of punches is only done in the progressive die. We will see separately what are the various types of dies we are using, that is simple die, compound die, progressive die, combination die, like that. So basically see here, the staggering of the punches is done only in the progressive die where the blanking is the last operation. Okay, so what is mean by staggering? So as in progressive die, at one stroke more than one operations are carried out. So basically there are having more than one punch. Okay, so here this is our stock or sheet and this is the die. So what I am doing here, this is our punch plate on which the punch are getting mounted. This is the die 1 and this is die 2. So here see, I am going to stagger the length of the punch. So say this is punch 1, P1, this is punch 2, this is die 1 and this is a die 2. Okay, now see here what I have done here. So I have reduced the length of one punch, that is I have staggered the length of one punch. So what will happen when this punch is going to apply the force onto this sheet or the stock? So here punch 2 will start its work by the time punch 1, or when the punch 1 is going to finish its work. Okay, see here, say the force applied by the punch is say F max 1 here and the force applied by the punch 2 is F max 2 here. Okay, now let us consider that if you are not provided any kind of the staggering here for the length of the punch, what will happen? अगर यहाँ पे कोई stagger हमने provide ही नहीं किया होता तो क्या होता? So it should be about this. This is P2. Okay, अगर हमने stagger किया ही नहीं होता, then what happened? The force which is acting on the sheet is nothing but what? The force by punch 1 is F max 1 and the force on the total, I am talking about total force, will be what? This F max 1 plus F max 2, because both are acting instantaneously at a time. So definitely the forces is quite huge, isn't it? Because we are taking as a total force, maximum total. But here now, because of the staggering of these punches, what happened? The punch 1 will or punch 2 will start its operation when punch 1 is going to finish its operation. When punch 1 will travel into the die, its cutting action, whatever the action is, once get completed, by the time punch 2 is going to start its operation. So no, these two forces are acting at a time. You can see here. So when I talk about what is the maximum force here in this operation, when the length of the punches is staggered, then definitely I can write this maximum force here is either of F max 1 or of F max 2, जिसमें से कोई भी जो maximum होगा, the maximum of either F max 1 or F max 2, whichever is the maximum force, that will I call it as the maximum force in this operation. But previously when the no staggering was there, this F max 1 and F max 2 was togetherly acting into the onto the sheet, into the operation, isn't it? So the forces were so high, isn't it? But because of the staggering of punches, I can reduce the force, that is only the maximum of these out of 2, only the maximum of these two forces, I can have that as a maximum force, isn't it? So this is how in this method that is staggering of punches, we can minimize the force F max. Okay, but the thing is that the balance, when you are staggering the length of the punches, definitely the balancing of the punches is quite difficult. That is the limitation. Now dear student, the third method that we are going to discuss is that for reducing the force is the shear as well as staggering. Provision of shear as well as stagger. The shear and stagger are together. If third method is what? The shear and stagger, or shear and stagger the punch or the punches. Okay, so see here, this is already staggering, then provide shear on one. So suppose I am providing the shear on this punch. Okay, and one of the combination I am doing like this, suppose. So definitely you will say, yes sir, definitely the force is going to, still it is going to be again lower and lower in the third case by the second case. Yes, definitely, by you are staggering the punches as well as you are providing the shear on the punch or onto the die, so of course the forces are going to be minimum. But see here, the balancing of the punches are again very difficult, and please remember that nowhere in the industry anyone can use such a kind of technique to minimize the force in the sheet metal work. Please remember, no doubt the forces is to be, or the force is to be very less, but the difficulty in balancing of the punches is very high. No one is going to use in any of the industry, please remember. So these are the three methods by which we can able to minimize the force in the sheet metal operation, specifically in punching and blanking. Okay, thank you.